we have another statistical test. This time it's the chi-square test, which works only with categorical data. And again, it's a statistical measure, not a distance. Unfortunately, to make things a bit harder for us, it is also in a range 0 to plus infinity. So we cannot that easily determine how strong the drift actually is. And as you will see in case of chi-squared, it is actually much harder than in case of Wasserstein distance even. So the intuition, the test statistic is a bit more complex than the KS test, but what it does is basically it takes the weighted average in a sense, and it's really weighted average in quotes because the formula is not a weighted average, but you can try to understand as kind of a weighted average of the differences in frequencies between all of the categories. So basically this difference, and right here we can take a weighted average, not fully but slightly weighted average, and that's how you will get your chi-squared statistic. And the way it's implemented, and the default implementation that we decided for the time being to go with, has one interesting property, and I would say potentially a drawback, which is the sample size actually influences the statistic for the same drift in magnitude. So imagine that you have two categories where the drift is 50% moved from one category to the other. And the chi-square statistic will actually increase with the sample size. So if you have a sample size of 100 for one test, and then in your next chunk you have 1,000, and your chi-square statistic is actually going to be influenced by the sample size, which potentially can lead to very confusing results or misleading results. It is also sensitive to changes in low frequency categories because it looks at this difference in frequencies, and it outputs chi-square statistic and p-value. So basically, it unfortunately has quite a lot of drawbacks, and we generally don't recommend using it, even though it's one of the standards for drift detection categorical features. And the results here, I'm just going to show you what happens if you don't go with the thresholds on the statistic, but you go with the p-values. So here we have our reference data, and of course there's no alerts displayed on reference data, but you can see that there's quite a lot of variance when it comes to our reference data. And now if we compare every single chunk of analysis to the reference data as a whole, because the sample sizes are quite big, it's gonna actually say that the distributions are statistically different for every single chunk of our analysis data, which is obviously not true and not really relevant from us. Sorry, it's true from statistical perspective, but it is not relevant for us from ML monitoring perspective. And that's why using p-values to determine the significance of your drifts is generally not a good idea from just practical perspective.